Let's open our journal today and continue our discussion on energy. We left off with electric energy, and we're ready to move on in our journal notes to some other forms of energy. So, thermal energy is our discussion to begin with. So, all objects have particles that are vibrating. The thermal energy in an object will increase when the particles move faster, and the temperature will increase. For instance, look at the toaster that is there below. The toaster is heating the particles of air that are around the toaster itself. Those particles begin to vibrate faster. That faster vibration causes the air above the toaster to heat. Look at the iron. The iron above is going to be ironing clothes. You put the iron on the clothing. The iron will then cause the particles that make up the clothing to vibrate faster, therefore causing the clothing to heat up. Let's look at the hair dryer. The hair dryer has a motor which blows air across coils. The air that's going across those coils is getting heated. The particles of air begin to move faster. Therefore, their temperature increases. Look at the picture below there about thermal energy that would be in water. So let's look at each of the pictures. Notice the first picture. It's a glass of ice cubes. Those ice cubes have particles that are very closely spaced together. So if you look at the picture there of each of the individual particles of water, those particles are very tightly bound, and they have very, very close bonds, and they are spaced very closely together. They are in a fixed position. They don't have a lot of kinetic energy because they are not vibrating very much. That also means if they're not vibrating very much, that they have a very low temperature. Let's go on and look at the particles of water in a lake. These particles of water in the lake can move more freely and have more kinetic energy than the water particles in ice do. They have more kinetic energy because they're not bound as closely together. Therefore, they are allowed to move more. That movement is, remember, kinetic energy is the energy of motion. So the movement of those particles allows the temperature to increase slightly. Therefore, this lake is not ice any longer. It is now water. These particles are moving, their temperature is increasing, making this be water, versus these particles are not moving very much. They're closely bound, so their temperature is lower, causing them to be a solid as an ice cube. Let's move over to the last picture. The particles of water in steam move very rapidly. Look at their movement in the circle above. That is movement of those particles. They're spread apart and they're moving very fast. Therefore, since they have a lot of kinetic energy, they have more energy and the particles are moving, so their temperature is higher. They have a higher or a hotter temperature. Electromagnetic energy is another one of the other forms of energy that we're going to discuss. So let's look at the different examples of electromagnetic energy. We abbreviate electromagnetic energy as EM energy. So in electromagnetic energy, we see a variety of energies there: light, gamma rays, X-rays, UV rays. You've probably heard of UV light. That stands for ultraviolet light, ultraviolet energy. Infrared rays, microwaves, and radio waves. So we see some examples of all of those different forms of energy. We will delve further into those at another time. The last other form of energy I'd like us to talk about is nuclear energy. So nuclear energy is the energy that's stored in the nucleus of an atom. Nuclear reactions on Earth can be made, they're man-made, and we use those as atomic bombs, if you've heard that used before, coming from the word atom. You also might have heard it called a nuclear bomb. So nuclear bombs are the releasing of the energy in the nucleus of the atom, and that is a use of nuclear energy. In the other than on Earth, naturally, we can have nuclear energy occurring in the sun and other stars, and we call those reactions fission and fusion. So there are nuclear reactions that are going on constantly in our stars or in our sun. So there's our discussion on nuclear energy. The last thing I'd like you to look at with me today is if you're looking at these two pictures, the football and the pool balls and the cue stick, if you will look at each of those and think for me as you look at those pictures, when each of these will have, number one, when will those have kinetic energy, and when will they have potential energy? Thank you for listening today. I hope you have a great evening. See you. Bye.